Hi everybody. In this video we are going to be looking at the solutions to the complex circuits worksheet. These are called complex circuits because they are a combination of series and parallel circuits together. Now these can be a little bit confusing at first, but if you take it step by step and simplify one set of resistors at a time, you'll see that they're not too difficult. So let's see what we're given in this problem. We are given the total current of the circuit right here. And I know that's the current for the total circuit because it is not where the circuit branches out into two different paths. It's the one path that leads back to my battery. And I am given the resistance of each of the three resistors. And if I look at how these resistors are drawn, and actually let's see if we can just sketch out the path of the electricity here. If the electricity comes out of the battery, it has to go across the R1 resistor and it gets to this point, and it can do one of two things. It can go down across the R2 resistor and back to the battery, or it can follow a different path and go across, across the R3 resistor and then back to the battery that way. So there's two different paths that the electricity can follow. In order to simplify this down, and let me just try to erase a couple of things here. In order to try to simplify this down as much as I can, I know that at first I'm going to want to find the equivalent resistance of the R2 and R3 resistors. Now they are in parallel with one another, so I'm going to have to use my parallel formula, my parallel circuit formula, I should say. And I know that the inverse of the 12 ohm resistor plus the inverse of the 6 ohm resistor, and I take the inverse of the sum of those two, that is going to give me an equivalent resistance for resistors 2 and 3 of 4 ohms. And I know that this combination here, the 2-3 combination, is in series with the R1 resistor. So I can find the equivalent resistor by simply adding the R1 resistor of 8 ohms plus the equivalence of my 2 and 3 resistors, which was 4 ohms, and that's going to give me a total equivalent resistance of 12 ohms. The next thing that they're going to ask us to find is the total current going through the circuit. And again, we've already identified that. It's not something we need to calculate. It was a given. That's 3 amps. Next, they're going to want us to find the total current of, or the total voltage of the current. The total voltage of the circuit is what I'm trying to say. So we're really looking for the voltage going across the battery here. And in order to find the voltage going across the battery, I have to multiply the total current of 3 amps times my equivalent resistance of 12 ohms. And multiplying those two together is going to give me a total voltage of 36 volts. The next thing they want us to find, let me just clean this up here. The next thing that they're going to want us to find is the voltage going across resistor 1. Well, I know resistor 1 is before the current or the circuit branches into two different paths, so I know I need to use the total current of the circuit of 3 amps and multiply that by the resistance of resistor 1, which is 8 ohms. 3 amps times 8 ohms is going to equal 24 volts. The last things that they want us to find are the voltages going across resistors 2 and 3. Now, because resistors 2 and 3 right here are in parallel with each other, I know in a parallel circuit, the voltage is going to be the same across each branch of the circuit. So I know the voltage going across resistor 2 is going to be the same as the voltage going across resistor 3. And I know if I add the voltage going across 2 and 3, add that to the voltage going across resistor 1, that's going to give me the total voltage of the circuit because these two things are in series with each other. So I know that in a series circuit, the voltage is going to be shared, and that's equal to the total voltage of the circuit. So I know the total voltage of the circuit is 36 volts, and I know the voltage across resistor 1 is 24 volts. Which means that the voltage going across both resistors 2 and 3 is going to be the difference between those two. So 36 volts minus 24 volts is going to give me a voltage of 12 volts. Problem number 2. We are given the voltage across the battery of 40 volts, and we are given the resistance of each of the 3 resistors. The first thing they want us to find is the equivalent resistance, and we're going to do that very similar to how we did it for the first problem. I know, again, first of all, let's just follow the path of our current as it leaves the battery. So the current is going to leave the battery. It is going to come to this junction first, and it can do one of two things. You can go across the R1 resistor, then across the R3 resistor, and back to the battery, or the current can come out of the battery, go all the way over through the R2 resistor, then across the R3 resistor, and then back to the battery. So I know that in this circuit, the R1 and the R2 resistors are in parallel with each other, and that combination is in series with the R3 resistor. So the first thing we need to do is find the equivalent resistance for the R1 and R2 resistors. R1 resistor is 30 ohms. The R2 resistor is 30 ohms. We add up those inverses and take the inverse of that answer, and we are going to get an equivalent resistance for resistors 1 and 2 of 15 ohms. Then to find the equivalent resistance, we add that 15 ohms to the resistance of resistor 3, which is 5 ohms, and we will get a total equivalent resistance of the circuit of 20 ohms. Next, we need to find the total current of the circuit. And to find the total current using Ohm's law, I have to divide the voltage going across the battery by the equivalent resistance. So 40 volts divided by 20 ohms is going to equal 2 amps. And the dog is barking at something. All right, everybody, this is what was causing the noise. Say hi to Molly. Molly, say hi to everybody. Say hi. Yeah, good girl, Molly. You're a good girl. You just wanted a little treat or something. We didn't treat you. All right, here you go. All right, let's get back to the problem. Where did I leave off? I think I left off with the total current. So now, after the total current, they wanted us to find the current going through resistor number 3. So I know the current going through resistor number 3 has to equal the total current of the circuit, because resistor 3 is not on one of the branches of the circuit. It's where the branches come together and make their way back to the battery. So the current on resistor 3 is going to be the same as the total current of the circuit, which was 2 amps. After that, they want us to find the voltage on resistor 3. And I know the voltage of resistor 3 is going to equal the current of resistor 3 times the resistance of that resistor. 2 amps times 5 volts is going, or 2 amps times 5 ohms is going to equal 10 volts. Next, they want us to find the voltage going across resistors 1 and 2. And because resistors 1 and 2 are in parallel with one another, I know that the voltage is going to be the same across each of those. And the voltage going across each one of those is going to be the difference between the total voltage of the circuit and the voltage going across resistor 3. So 40 volts minus 10 volts is going to give me a voltage of 30 volts going across resistor 1 and 30 volts going across resistor 2. To find the current going across resistor 1, I know that my voltage going across that resistor is 30 volts. The resistance of that resistor is 30 ohms, so 30 volts divided by 30 ohms is going to give me 1 amp. And I'm going to do the same exact thing for the current going through resistor 2, because the resistance of resistors 1 and 2 are the same. It's going to be the exact same thing and give me 1 amp. And again, a good way to double check our work is just to see that if I add up the current going through each of the individual resistors in the branch, it's going to equal the total current of the circuit of 2 amps. Problem 3. We have a 20 volt power source and is supplying power to a circuit that has 4 resistors, and we are given the resistance of each of those 4 resistors. Let's start off by taking a look at how these resistors are grouped. I have resistors 2 and 3 that are wired in series to one another. they can form an equivalent resistance that is in itself wired in parallel with the R4 resistor. And this 2, 3, 4 resistor combination is wired in series with resistor 1. So let's start by looking at the equivalent resistance between resistors 2 and 3. Because they are wired in series, I simply have to add those resistances up. And 6 ohms plus 4 ohms is equal to 10 ohms. So now I know that this equivalent resistance is equal to 10 ohms. Now I can find the equivalent resistance between the 2-3 combination and resistor 4. To find that equivalent resistance, I know because they are in parallel, I have to use my parallel resistance or parallel circuit formula for equivalent resistance. So I know that the 2-3 combination has a resistance of 10 ohms. Resistor 4 has a resistance of 10 ohms. So that will make the equivalent resistance of this entire combination of 3 resistors 5 ohms. That 5 ohm equivalent resistance is now in series with resistor number 1. So to find the equivalent resistance for the entire circuit, I simply have to add the resistance of resistor 1, which is 5 ohms, to the resistance of my combination of resistors 2, 3, and 4, which is also 5 ohms. And that is going to give me a total resistance for the circuit of 10 ohms. The next thing that they are asking us to find is the total current of the circuit. So I know that the total current of the circuit is going to equal the voltage going across the battery, which is 20 volts, divided by my equivalent resistance, which is 10 ohms. 20 volts divided by 10 ohms is equal to 2 amps. The next thing that they're asking us to find is the current going through resistor 1. And because resistor 1 is not on one of the branches of the circuit, it's on one of the main leads coming off of the battery, or it's part of the circuit before it branches off into 2 separate paths, I know I need to use the total current of the circuit for resistor 1. So the current going through resistor 1 is going to equal the total current of the circuit, which is 2 amps. Now that I know the current going through resistor 1, I can find the voltage going through resistor 1. So the voltage going through resistor 1 is going to equal the current going through resistor 1 times the resistance of that resistor. So 2 amps times 5 ohms is going to give me 10 volts. Now I know that the voltage is going to be equal across both branches of the parallel portion of my circuit. So as I go along this branch of the circuit and this branch of the circuit, I know that the voltage is going to be the same for both of those. So to find the voltage going across resistor 4, I know that is going to be the total voltage of the circuit, 20 volts, minus the voltage of resistor 1, or the voltage going across resistor 1. So 20 volts minus 10 volts is going to equal 10 volts going across resistor 1. Or, I'm sorry, going across resistor 4. And then to find the current of resistor 4, I just have to divide the voltage of that resistor by the resistance of resistor 4. So 10 volts divided by 10 ohms is going to give me a current of 1 amp going through resistor 4. Problem 4. We are not given the voltage of the circuit, but I know that the total current is 4 amps. I'm given the resistance of each of the 4 resistors. And if we take a look and see how these resistors are grouped, I have resistor 1 and 2 that are wired in parallel with one another. And that combination of resistors is wired in series to resistors 3 and 4. So if I first find my equivalent resistance between resistors 1 and 2, which is the inverse of 4 ohms plus the inverse of 4 ohms and the resistance, the inverse of that sum, that's going to give me an equivalent resistance of 2 ohms for the resistor 1-2 combination. Now I can find the equivalent resistance for the entire circuit by simply adding that equivalent resistance for the 1-2 combination plus resistor 3 plus resistor 4. And when I do that, I have 2 ohms plus 6 ohms plus 7 ohms is going to equal a total equivalent resistance of 15 ohms. To find the total current of the circuit, that's already given to us. It's 4 amps. And now that I know the equivalent resistance and the total current of the circuit, I can find the total voltage of the circuit. Using Ohm's law, I know what it is. The total voltage is going to equal the total current times the equivalent resistance. So 4 amps plus 15 ohms is going to equal 60 volts. Once I have the total voltage, I can now find the current going through resistor 1. Now remember, let me just clear off some of that stuff. As the current, this 4 amps comes over here in a parallel circuit, right? Some of the current is going to go through resistor 1, and then some of the current is going to go through resistor number 2. The current is going to be shared among the resistors in a parallel circuit. Because resistor 1 and resistor 2 have the same resistance, they both are 4 ohms, they are going to share the current equally, which means that of the 4 amps that are coming into this parallel part of the circuit, 2 amps are going to go through resistor 1 and 2 amps are going to go through resistor 2. Because the resistance is the same, they're both 4 ohms, they're going to share the current equally. So I know that the resistance or the current of resistor 1 is going to be 2 amps. And as I come back to resistor 3, as both of these paths of the circuit combine again and we start to move down through resistor 3, those 2 amps going through resistor 1 and the 2 amps going through resistor 2 are going to join together again and combine to make 4 amps all over again. So I'm going to have 4 amps going through resistor number 3. And to find the voltage of resistor number 4, because again I know that my current going through resistor 4 is going to be 4 amps. The resistance of that resistor is 7 ohms. 4 amps times 7 ohms is going to give me a total voltage for resistor 4 of 28 volts. Problem 5. So in problem 5, we are given 3 resistors. We know the resistance of 2 of them, resistor 1 and resistor 3. We don't know the resistance of resistor 2 yet. I know the voltage across resistor 2 is 4 volts, and the current across resistor 2 is 2 amps. I know the voltage across resistor 3 is 8 volts. The first thing that they're looking for, or asking us to find, is the resistance of resistor 2. Before I do that, let me just make a quick note on how the circuits are drawn, and this should just be reviewed from the PowerPoint that Mr. Broderick reviewed with you guys. But remember, when we're drawing circuit diagrams, the voltmeters always have to be wired in parallel with the resistor. So we see the voltmeter is in parallel with the resistor, and the amp meters always have to be in series with the resistor. So if we look to see how this circuit is drawn, I have resistor 1 and 2 in parallel with one another, and that combination of resistor 1 and 2 is in series with resistor 3. So to find the resistance of resistor 2, I'm given the voltage and the current going through that resistor. So to find the resistance, I simply divide the voltage by the current. 4 volts divided by 2 amps is going to give me a resistance of 2 ohms. The next thing that they're asking us to find is the equivalent resistance of the circuit. So to find the equivalent resistance of the circuit, I'm first going to need to find the equivalent resistance between resistors 1 and 2. Because they are wired in parallel, I'm going to use my parallel circuit formula. And I plug in my 2 resistances, 2 ohms and 2 ohms. That will give me an equivalent resistance for resistors 1 and 2 of 1 ohm. Then to find the equivalent resistance for the circuit, I add that 1 ohm to the 2 ohms of resistor 3 because they are wired in series, and that will give me an equivalent resistance for the entire circuit of 3 ohms. Next, they're asking us to find the current going through resistor 3. I know the resistance is 2 ohms and the voltage is 8 volts. So the current is going to be 8 volts divided by 2 ohms, voltage divided by resistance, and that will give me a current going through resistor 3 of 4 amps. The total resistance for the circuit is going to be the same as the current going through resistor 3 because resistor 3 is not on one of the branches of the circuit. So all the current has to go through that resistor. So the total current of the circuit is also 4 amps. The total voltage of the circuit is going to be my total current times my equivalent resistance. So 4 amps times 3 ohms is going to give me a total voltage of 12 volts. And just as a quick note here, it's also going to be the sum of my voltage going through resistor 3 and my voltage going through resistor 2. So if I add those two together, I should also get 12 volts. Just a good way to double check your work. And to know the voltage going across resistor 1, because resistor 1 is in parallel with resistor 2, I know that the voltage is going to be the same across both branches. So because the voltage of resistor 2 is 4 volts, the voltage going across resistor 1 is going to be 4 volts as well. And to find the current across a resistor 1, I know it's the voltage divided by the resistance. So the voltage of resistor 1 is 4 volts. The resistance of resistor 1 is 2 ohms. 4 volts divided by 2 ohms is equal to 2 amps. Last but not least, problem 6. In problem 6, we are given the total voltage of the circuit, which is 30 volts. We are given the resistance of resistor 2, 6 ohms, the resistance of resistor 3, which is 12 ohms, and the voltage going across resistor 1, which is 6 volts. First thing that they are asking us to find is the voltage going across resistor 2. Now, I know the total voltage of the circuit, and I know the voltage of resistor 1. Remember that in the series circuit, the voltage is, the voltage is going to be shared among each branch of the circuit or among each component of the circuit. And for the parallel portion of the circuit, resistors 2 and 3, which are in parallel with each other, the voltage is going to be the same across each of those resistors. So the voltage going across resistor 2 is simply going to be the total voltage of the circuit, 30 volts, minus the voltage going across resistor 1, which is 6 volts. And that's going to give me a voltage across resistor 2 of 24 volts. The voltage going across resistor 3 is going to be the same as the voltage going across resistor 2 because they are parallel to one another. So the voltage going across resistor 3 is also going to equal 24 volts. To find the current going across resistor 2, I have to divide the voltage of resistor 2 by the resistance of that resistor. So 24 volts divided by 6 ohms is going to equal 4 amps. I'll do the same thing to find the current going across resistor 3. I'll divide the voltage going across that resistor, 24 volts, by the resistance of that resistor, which in this case is 12 ohms. So 24 volts divided by 12 ohms is going to equal 2 amps. And across resistor 1, or the current going across resistor 1, is going to equal the sum of the current going across resistors 1 and 2, because remember the current is coming out of the battery, it's going across resistor 1, then it's being split between resistor 2 and resistor 3. So the sum of resistors 2 and 3, or I should say the sum of the current going through resistors 2 and 3 will equal the amount of current going through resistor number 1. I'm trying to erase this and it's not letting me. So the current going across resistor 1 is going to be 4 amps plus 2 amps, and that equals 6 amps. Now I know the voltage of resistor 1, and I know the current going across resistor 1. I can find the resistance of resistor 1. The resistance is going to equal the voltage divided by the current. 6 volts divided by 6 amps is going to be 1 ohm. So that's the resistance of resistor 1. And the last thing that they're asking us to find is the equivalent resistance. So again, I know that resistors 2 and 3 are parallel to one another, and that combination of resistors 2 and 3 is in series with resistor 1. So the first thing I want to do is find the equivalent resistance between resistors 2 and 3. So 6 ohms, or the inverse of 6 ohms plus the inverse of 12 ohms, and the inverse of that sum is going to give me an equivalent resistance for those two resistors of 4 ohms. And I simply have to add that 4 ohms to the resistance of resistor 1, which is 1 ohm. So 1 ohm plus 4 ohm is going to give me a total equivalent resistance of 5 ohms.